So hello everyone, good day. We will be discussing the fundamental concepts of signal spectra and the signal processing. So focusing specifically on the classifications and the characteristics of the signal. So unsa man jud ng signal. So what does it mean? So in signal processing sa to ang course karon is a system analysis. A signal is defined as any physical quantity that varies with one or more independent mga variables such as sa time, sa mga space, sa ato ang space or frequency. And its primary purpose is that it carries kanang mga useful information. So muna siya mga primary purpose of it. So understanding these classifications is highly essential kay ato ni siya magamit and kini ang ato ang foundation parameters if we want to analyze sa ato ang mga circuits and design communication systems, which is more likely important here in our course sa tuwa course. Process data. So karon it as break down the major characteristics of signals and also explain their characteristics as well as their applications in our field. Let's start with our first classification, which is the continuous time versus discrete time signals. So diri ang basehan na nato is whether the time axis is continuous, or discrete, meaning countable. So in continuous time signals, it contains a value for all mga real numbers along sa time axis. So it is represented mathematically as x sub t, or x sub t, where t can take any real variable. So meaning define siya for every continuous instant of time. So for example, ang continuous acoustic speech waves, mga analog voltage waveforms in sa mga analog synthesizers or sa mga physical temperature monitoring over time. So much since it is continuous. Next is we have the discrete time signal. So in contrast, a discrete time signal only has values as specific. So equally spaced intervals along the time axis. So mathematically, it is represented as xn, where n is an integer representing the sample index. So these are often created by sampling a continuous time signal. Relatable examples ani kay include mga digital audio processing like CD, mga MP3 files, mga stock market closing prices recorded daily, and also mga digital image pixels. Moving forward, let's look at pattern repetition. So we have the periodic versus aperiodic. The periodic signals, a signal is aperiodic if it repeats its core pattern at regular, so predictable intervals siya. So we define a periodic function mathematically using the expression as seen or as to what I've placed in this screen. So where t is a positive constant and the fundamental period of our function is the smallest value of t that still allows this equation to be true. So like for examples, or mga sinusoidal power lines like 60 Hz AC and utility power local oscillator, clockwise in digital microcontrollers, and mga musical synthesizer tones. We have the aperiodic or non-periodic signals. These signals that do not satisfy the periodicity condition and do not repeat themselves at regular intervals, unlike sa other nga akong explain. So the common examples include human speech transients, lightning strikes, and random circuit thermal noise. So those are the difference between them. Next is we have the finite versus infinite length signals. So kaning nga classification is in terms of the signal's length along its time axis. So Is the signal defined for all possible values of time or for only certain visuals? So here, the finite length signals is a function of ft finite length signals if it exists only within the strictly bounded time interval. So, na siya naka-strictly bounded na siya. So, outside this tracking window, the signal is exactly zero. Regarding energy class, there are almost always energy signals, meaning they have finite total energy but zero average power. So, for examples, we have mga Wi-Fi data packets, radar pulses, a signal hand clap, and digital window functions. So, in infinite length signals, on the other hand, an signal that extends indefinitely toward positive infinity, negative infinity, or both. So it depends. The duration is completely unbounded, defined for all values from t greater infinity and less than infinity. So these typically belong to the power signals class, which features infinite total energy but finite average power. So, application in this, or for example, include is the 60 hertz AC power grid lines, mga continuous clock signals and microchips, and also our background thermal noise. Next is we have the casual versus anti-casual versus non-casual signals. So now, let us discuss how signals behave relative to time zero reference parameters. So first we have the casual signals. So here in the casual signals are signals that are strictly zero for all negative time. So mapansin ninyo yun in the real-time physical systems that cannot respond before an input is applied, such as the output response of the mga RC circuit right after a switch is closed. So, di na dyan siya. So, next is we have the anti-causal causal signals. So, these are signals that are strictly zero for all positive time, unlike atong sa isa. So, kinahanglan ni siya tracking theoretically back propagation analysis and reverse time signal processing in post-recording software. So we have also non-causal signals. So these signals have non-zero values in both positive and the negative time domains. Unlike sa duha, nga ta isa-isa ra jud siya whether it is negative or the positive. So relatable applications feature spatial image processing where the coordinates are spatial like the left and right sides of a center pixel rather than forward or backward in physical time. So those are the relatable or applications of it. Next up, we are going to talk about symmetry properties, even versus odd signals. So even signals and even signals is any signal such that f of t is equals to f of negative t. So even signals can be easily spotted because they are symmetric around the vertical axis, meaning reversing the time axis yields the exact signal. So examples of these includes cosine waveforms used in Fourier analysis, especially on if you are kanang kabaluan ng mga Fourier methods in sa advanced math, and symmetric filter kernel designs like zero phase like or what we call FIR filters. So next is the odd signals. And odd signals, on the other hand, is a signal such that f of t is equals to negative f of negative t. So they are antisymmetric about the origin, so the reversing the time axis completely negates the signal amplitude. So prime example of these are sine waveforms. So unlike the is the cosine, here is sine waveforms used in spectral decomposition and quadrature phase shift networks. So take note guys, using the definitions of even and odd signals, we can show that any signal can be written as a combination of an even and odd signal. So every signal has an odd or even decomposition. So nago na siya tanan ang mga expression. Finally, let's look at predictability parameters, which is the deterministic versus random. So here in deterministic, it is a signal in which each value is fixed and can be fully determined and predicted by an explicit mathematical formula. So rule or lookup table. So there is absolutely no uncertainty. For example, look at the signal function. So this signal is continuous time. So it means that analog, periodic, infinite length, causal, and by definition, deterministic. Other examples include test calibration signals like sine waves generated by functions, generators, and carrier waves used in standard RF modulation. Next is we have the random signals. On the other hand, the values of a random signal are not strictly defined and are subject to some amount of variability. So they are completely unpredictable and cannot be described by a simple mathematical equation. So dili gyud siya maayo. So they can only be modeled using statistical properties like mean, variance, and probability, mga density functions also. So common examples of these is or are include thermal noise in electronic components, wireless channel interference, and seismic vibration. So to sum it up, knowing how to classify these different kinds of signals helps us pick the right mathematical tools to process and analyze them correctly. So mao rato for our activity 1, which is the classification and the characteristics of the signals.